Google Chrome. Okay. So you'll find some material there. uh, I would be referring to that lecture material. Okay. Okay, so let us continue with what we had left in the afternoon. uh, in the art studio. Okay, so we were talking about uh, the sort function. And okay, so the other thing is, so we have talked about how to generate regular sequences. Okay. So we can use the colon operator to generate a sequence of numbers. Let's say 1 to 100. If I want to generate a sequence of numbers from 1 to 100, then I can use this colon operator over here. I could also use the seq function. Okay, the sequence function over here. All right. So there are some arguments in this sequence function. So let's say again you use the help. Okay, and the possible arguments in this seq function are from and to. Okay, and by, the length of output and along with. So you can read about the arguments in this help page, but the most important arguments would be from and to. So to do the same, I would use seq and do from is equal to 1 to equals to 100. So this will generate a sequence of numbers from 1 to 100. So line 33 and line 35 will give you the same result. But there's a point over here. Like there's an important point to understand. Uh, there are some arguments like by and length dot out. Okay. So one argument like by lets you generate a different series of number. So by increment of the sequence. So if you do by equals to 2, then you will not get a sequence of numbers from 1 to 100. I mean, like here the output will be different from this line number 33, in the sense that the output of line 35 or the code in 35 will give you values like 1 3 5 7, the odd numbers. Okay, so you can generate a sequence of odd numbers from 1 to 100 using this function, which you will not be able to do using the colon operator. Also, you can use the repeat function. Okay, which is similar to the sequence function. Okay, okay, let me finish this. So repeat, let's say you could repeat anything. Let's say you could repeat 1 and times is, let's say, 10. So you could repeat 1 10 times. So the output, instead of keep typing 1 10 times, you could just use the rep function to generate number so many times. All right. Okay, one important thing that I wanted to tell you is that, like, for example, when you are using this seq function, there are 3 arguments over here. So normally we write the argument also over here, from to. Okay, uh, we could also ignore, just put in the values 1, then 100, then 2. Okay, so if you run this also, you'll get the same output. Okay, as you can see on the console. But the point here is you have to provide the input like 1, 100 or 2 according to the position of the argument in the function. Okay, so for example over here in this seq function, what you see is the first function argument is from, the second argument is to, and the third argument is by. So I have put this values 100 and 2 according to according to these arguments, the sequence of these arguments. So if you by mistake instead of the by, so if you had type 2 and 100, so like you might be thinking in your mind that this one is from 1 increased by 2, and it will end up at 100. So this could be your logic of understanding, but if you run this, you'll get something else. Okay, so if you want to do that in a random way, not in the default sequence of the arguments, then you should type in the arguments like from, then by, and to. So now it doesn't have to be in that sequence because you have already mentioned the arguments over here. Okay, now this will give you the same result. So while entering while writing the arguments within a function, you should be very particular about the sequence of the arguments if you are not writing the arguments within a function. That's one thing. Okay, moving on. There's another function like paste. Okay, this is a very important function. Mostly you can do that if you can use this while working with characters. Okay, so in this line of code, okay, what you see is that it says paste value or a character A, okay, with the numbers 1 to 10 separated by they're just inverted commas over here. So basically means it's separated by nothing at all. Okay, so it's not actually separated. So you can so when you do that, this is the output that you will see over here. Okay, so when you print x, then the letter A is printed to 1. Paste it will get it will paste it to 1, then A1, then A2, A3 up to A10. Okay, similarly you could also do this. Okay, so x and y, so more than one. So here it was just one element, now you have more than one element. Again, when you are using more than one element, you'll have to use the C function, and especially when the elements are separated by a comma, then it's important to use the C function. So paste x and y with 1 to 10, and this is the output that you will see. Okay, and it's separated by nothing. Here it's again the same. So the separate function, SEP function, let me just copy this over here. So let me put it as I. Okay, so here if you print I, so it's like x1, y2, x3, y3, so on and so forth, and there's nothing over here. So if you use anything okay, within this code. So let's say if I use a dash, okay, then x and 1 is separated by a dash over here. If I use something else, let's say star sign, then x star 1, x y star 2, so on and so forth. So that is the use of the SCP function argument. And there's one more argument which is called the collapse. This is useful when you want to collapse the entire to collapse the entire output into a single string over here. Okay, so if you use this collapse argument, so let me just use this collapse argument over here. So now, okay, just have a look at this output over here. Okay, so it's x1, x 6, 7, 8, 9, 10 elements. So length of I, if you check the length of I, it will say 10. So there are 10 elements in this vector I. All right. Now, if I use the argument collapse, okay, I'll call it J, okay, and then check the length of J, then it will say it's 1. So the output is actually the same in the sense, the numbers, the alphabets are the same, but this has the length is 1 over here in this case, because everything is collapsed into a single character over here. So that is the use of this collapse argument inside the paste function. So so basically what I'm trying to tell you is that wait, so yes, so the functions like repeat, paste, sequence, okay, the colon operator, seq, so this will come very handy when you're actually working with strings, and you have to combine different kind of variables together. Okay, so these functions are very useful when you are doing that. Okay, the other important thing while you work with the base R is the working directory. This thing is will serve your purpose if you are actually not using RStudio. But since we are using RStudio, okay, I have already shown you how to create a R project and then save your files over there. Okay, let me quickly demonstrate you one more thing. So actually you can access all the files here also. So what I have done is I have downloaded a file. Let me just close this. Okay, I have, okay, like you might have any Excel file or Excel sheet, whatever, in your desktop. Okay, so and with the Excel file that you want to work with, or the CSV file that you want to work with. Okay, so simply click on this project folder and copy that Excel sheet. Okay, like for example, this Excel file or the CSV file, this is a CSV file. I have copied it from my desktop. Let's say it was there. Okay, there is a file over here, the Excel file over here. So simply I'll put it in this folder, copy paste, okay, or cut paste, whatever you want to do. So I just put it in this folder, the VB seminar folder, the project folder. Okay, now accessing this file. There was a phone call. Please let me know if my screen is visible and I'm audible.
Yes, sir.
Okay, thank you. So what I was saying, yeah, so I copy it and put it in this VB seminar folder or the project folder. Okay. So if you remember the project folder that we had created over here, VB seminar. And if you just check this fourth window or the lower right window, so you can see the file makeup filter dot excuse me dot xlsx over here. You can also find a CSV file education.csv. Okay. So creating a working directory is same thing as creating a project in R. Okay, so since we are working in R Studio, so I think it's more viable to be using our project rather than creating a working directory. Actually, it's the same thing. Okay, so now let's say you want to access this file education.csv, or let's say make up filter, whatever. So let's access this education.csv file. So sorry. So click on it. You'll either get a view file or import dataset. Okay. So import text data. This window appears, and here you can see. You can have a glimpse, okay, of the data. You have a data preview over here. Okay. Then name is education. The first row as names. So let me just show you the file. So this is the file. Okay. Oh, where is it? It's a pretty big file. As you can see, the file size it's about 6.6 MB. Okay, so it's a pretty large file. I'm trying to open it in Excel and show it to you. Yeah, so this is the file. So it has a data set. This is a data set on education, on education indicators. Okay. And it's for all the countries starting from Afghanistan to Zimbabwe. So it's like 30,000 rows of data. All right. So okay. So my point is now you want to use it in R. Work with R. So the first row as names. Okay. Delimiter is comma because this is CSV file. Trim spaces, open data viewer. Okay. So this will use the view function over here, view education. Okay, so this is the code preview. So first you need the read R package. Okay, because there are other functions also, like there's a function called or a code called read.csv. Okay, that comes from the base package. You can use that as well. This read underscore CSV is a function from the read R package. For those who have not, okay, like, so most of you might not have this read R package in your thing. are installed in a system. So you need to install this package, install dot packages, then read R within quotes. Okay. So why does RStudio recommend using the read R package? Because this is pretty quick. I mean fast. Okay, as compared to the earlier read dot CSV function. Anyway, so this comes up okay by default. So you can simply click on import, and here you go. The data is now, you have imported the data, the CSV file into R. Okay, and you can see there's a preview of this data set. Alternatively, this is one way of doing it. The other way of doing it is I will call it edu. Okay, and I will use the, like, for now you can do this. Okay, so one way, again I'm just repeating it. So one way is step number one, copy and paste the Excel file or the CSV file into the project folder. Okay, number one. Number two, as soon as you do that, in the files tab in the fourth window, you will find the file. Click on that file. You'll get an option, import dataset. Click on it, and then you just follow the instructions over here. Okay. Now, that is one way of doing it. The other and a very traditional way of doing it is to use the read.csv function. So the since we are using this VB seminar project, okay, so we have created a project, so it's pretty simple enough, okay, to import the file. So read.csv, and within quotes you give the name of the file. Okay, so sorry, education. So you can check the spelling and the cases, lower and upper cases, over here in the fourth window, education.csv, and you assign the entire thing to an object, whatever you want to name it. Okay, so on the left side you can name it as anything. So I will call it edu. Okay, and then run. So in the third window, I can see this edu file. It's a data frame, 35 okay variables. This is the size, 19.3 MB, and there are about 30,021 observations of 35 variables. Similarly, we had used if you remember, we had imported this same file, okay, but we had used another function called the read underscore CSV. Instead of the read dot function, we had used the read underscore CSV function. So what has this done is, this has actually changed the data, I mean the class of the object. Okay, so if you do class of edu, okay, then it will say it's a data frame. Now if you check the class of education, okay, the one that we had imported using read underscore CSV, the read Excel package, from the read Excel package, it says that it's not only a data frame, but it's a TBL, okay, or a tibble, and a special table data frame, and it's a table data frame. So the only difference is that here, when you have imported using the read underscore CSV function, you have got a more what can I say, flexible class to work with, class of the object to work with, or the form or the the class of the object uh, you know uh, is more flexible in the sense, if you are using some other packages, then still you'll be able to use the data set that you have just imported. All right, so I've just shown you two ways of importing the data set into your R. So now let us import this that XLSX, I mean the Excel file in that sense, with the extension XLSX. So simply click on it again, import data set. Okay, so you'll get a preview over here. All right. Remember one thing, that in base R, it's not possible to import the Excel file. Okay, because there's no function which helps you to basically you'll have to convert an Excel file into a CSV, and then basically you have to save it as a CSV. Okay, open Excel, save it as CSV, and then import into R. However, if you go beyond the base R, that is, like for example here we are using another package, against read Excel package. Okay, then there is a function called read underscore excel. That one will help you import the file. Again, the process is the same. All right, so I think yeah, so this will import the Excel file. Okay, and show you the file as well. Okay, so now okay, let me just do a quick formatting of this data set. I'll just show you the data set. This is a smaller data set to work with. It would be easier to make you understand. Now if you can see, there are excuse me, this is a spreadsheet format presentation of the data. You could see that the last three columns, column 8, 9, 10, okay, in fact 8 and 9 doesn't contain any data. Okay, there's nothing there in A. Okay, in A means missing data, missing information. And in the last column also, column 10 also, you'll find a negligible amount of data. Okay, so out of 1891 entries, okay, 1, 2, 3, 4, 5, only I think six entries. There are 6 entries in the 10th column. Okay, that's what we can make sense of by just a visual inspection. So when we are working with the data set, okay, we might not need these 3 columns. Now we want to get rid of these 3 columns. Okay, so makeup filter is the name of the data set over here. So name, so what you can do is you can either check this window, okay, makeup filter over here. You can either check this, like transaction number, name, date, project city, okay, product is in the date format, product. Actually there was a section I could have also talked about working with dates in R, but we can't do everything. Okay, so I'll just leave it for now. Then product, units, dollar, so everything is given over here. So you can so this 1, 2, 3 columns are the are those that we have to remove. Okay, so again, so in our environment now, or in our current session, we have this makeup filter. Okay, this is the name of the file, makeup filter. So what we do is we can use the function names and type the name of the file over here, or the variable names makeup filter. Let me just do this and run. So now here you can see that these are the names of the variables in this dataset makeup filter: transaction number, name, date, product. So we don't want these three. Okay, we don't want these three. So what we can do is, since these three names, these three columns appear consecutively, that is 8, 9, and 10. So this is what is called subsetting. Okay, so what we can do is type the name of the file, the object or the variable dataset makeup filter, and we use this bracket. This is mostly used for subsetting. Okay, so from the set of 10 columns, we will eliminate three columns. Okay, so now see, this is a hello. Okay, let me continue then. So this is a two-dimensional what can I say, object. Okay, two-dimensional in the sense it has rows and columns. Okay, therefore we have to talk about rows and columns when we are subsetting. So we say that in this object or the data set, data frame makeup filter, I want to separate it by a comma. So the first place would be your rows place. Okay, row, R-O-W, row, rows place. And the second place after the comma is the place for the column. Okay, so whatever changes that we want to do with the row, we will do it here on the left of the comma. And to the right of the comma, we will, whatever operations we want to do it for the column, we'll use the right side. Now, we do not want the last three columns, or in other words, we want columns 1 to 8, right? So we know the colon operator. So we are saying just keep the columns 1 to 8. Okay, but I do, but keep, yeah, and remove the other. That means it's removing 8, 9, 10. Sorry, 1 to 7. 1 to 7, and then remove 8, 9, 10. And I want all the rows. Okay, all the rows. So don't do anything with the rows. Just remove or just keep. Here I'm saying just keep the first 7 rows. Okay, this. So if I do this, okay, let me do. Okay. Not to complicate the code, I would suggest you to learn about what is called the pipe operator. Okay, this is called the pipe operator. This is just for your reference. The pipe operator, again recalling, I've used a hash mark. Okay, and this is a comment. Okay, the pipe operator. Okay, this is called a pipe operator. So literally which literally translates to and then. Okay, so basically this means and then. Okay, so what this function does is, it's like, since R is also a language, so it says that in the makeup filter, okay, file makeup filter, just keep the columns 1 to 7. Okay, so after that is done, it's saying that, and then you do this. All right, and then what you're going to do is uh, what was I trying to do? Oh, acha. And then give me the names of this. Give me the names of this makeup filter, and give me the names. All right. So I'll give you an alternative way of doing this also. So for this, you will need to install tidyverse package. Okay, dplyr. Let me check with the dplyr. If it works with the dplyr, then you don't have to library dplyr. Yeah, it works. So just do the dplyr. Okay. Excuse me. So I'm not doing this 46 because I already have dplyr installed. So just install dplyr package and then load the package. So we are doing a makeup filter. Okay, makeup. I mean the data set. We are just keeping columns 1 to 7, and after you do that, we are saying, and then give me the names of that object or the data frame, and then it gives me these names 1 to 7. So in makeup filter now, like this operation actually helps you select the whatever it helps you to deselect, I mean 8, 9 and 10, 3 columns. All right, or if you want to view, so you can do view, and then you can see that there are just 7 columns. That is location is the last column. Okay, so you won't find there are, like, I can't scroll beyond this. Okay, so so 7 total columns, as you can see over here highlighted. Okay, so this is one using the using the pipe operator, or what you could alternatively do is you could do names and then makeup filter, then comma 1 to 7. You could do this. Okay, it will give you the same thing, or you could use the view function over here. Actually, there is a philosophy behind using the pipe operator, because normally when you are coding, what happens is that you go inside out. Okay, so so first this takes place, and then this takes place. Okay, so it's as if you are coming out from the center and you are moving out. Okay, so sometimes visually also it's quite difficult to interpret the codes. So the philosophy of the pipe operator is that it's more lucid and it's more free flowing in nature. I mean, the codes become easier to interpret and visualize as well. Anyway, so you can either use this or that, whatever is convenient and suits you. The other thing that you can do is, so instead of saying 1 to 7, let's say I just need columns 2, 3 and 4, or let's say column number 2 and column number 6. Okay, so I could also use the names, okay, of the variables over here. So instead of so I could do this names and dollars. So there are only 2 columns now, or again the same code over here. I could use the numbers basically over here. So I could do what is that, number 2 and sorry, within C, number 2 and that is number 6. Okay, so this will also give me the same output over here. All right, So again, I'm just repeating it, how to subset a data frame. Okay, again, what is a data frame? A data frame is an R object. I think I've explained you what an R object is. And data frame is an R object which can contain multiple types of objects within itself. Okay, so as you can see, this is an makeup filter is a data frame. Okay, or a table, and it can contain different types of objects like character. Name is a character. Date is a it's a date object. Okay, project city, and product is a character object. Units is a number. Okay, uh, and so on. And these are logical. Okay, and so on. So affairs is a data set or a data frame, uh, which can contain objects of different types. So that's a data frame. And to understand it in a more better way, the Excel file, the CSV file that we normally come up with, okay, or that we usually work with, can be, okay, for now, just for an basic understanding, we could consider it as a data frame. Okay, so yes, yeah. So so that was one way of subsetting. So I was talking about subsetting. So this is what you could do. Okay, so yeah. So about subsetting, when you want to subset a data set or a data frame, so what you need is this bracket. So this bracket helps you in subsetting. Okay, so and within the bracket, as I was talking about earlier, you need to specify two things. One, whatever changes you want to do for the row, and the second is for the column, and they should be separated by a comma. Okay, so there's a comma, and to the left of it, whatever you do will change, will affect the rows, and on the right, after the comma, whatever you write will affect the columns. All right. Now the other way of doing the same, like for example here, let's say I want first column, third, fifth, and sixth. 1, 3, 5, and 6. So what you could do is simply you could type 1, 3, 5, 6. Okay, so 1, 3, 5, and 6. So you'll get 1, 3, 5, 6. There is four columns over here. Now getting back, let's say you do not want 1, 3, 5, 6. So the question was like remove these columns. So just put a minus sign over here and then run it. Okay, so it will give you all the other columns except those columns, as you can see over here. So here, if I had to do it in the other way, if I had to remove 8, 9, 10, then I would have done remove 8 to 10. Okay, there. Okay. So I could have used the names. So 1 to 7, no 8, 9, 8, 10, 10, 8 to 10. So that is subsetting. That was like, rows. So we are doing with the columns. Now what about rows? Okay, so let's have a look at the data set. So here it says that there are about 1891 entries, the transaction number. Okay, transaction number. So but in our analysis, let's say we need the first 1000 transactions. Okay, so up to here, transaction number up to here. So we don't want the rest of the data set. Okay, so we do not want rest of the data set. So up to the 1000 row number 1000. Okay, So what you do is, so you are selecting, yeah. So you are selecting. This time we'll do view. So we keep the column as it is. Now we go to the rows side and we say, give me numbers from 1 to 1000. I mean the rows from 1 to 1000. All right. So here you can see there are about 1000 entries, 7 columns. In the previous file, we had 1800 entries, 1891 entries. All right. So now we have 1000 entries. So that's how we subset. So the last one is this one, 1000. Okay. So we have now reduced a bigger data frame into a smaller data frame where we have reduced the number of columns and we have also reduced the number of rows. Let's say we okay, so now let's do something else. So let's say in this data frame, okay, the bigger data frame over here, okay, so in this data frame, let's say the entry over here, let's take an example. So let's say 1025th row, okay, 1025, this row number. So the entry, we have to include this entry. So the number of observations will be, I mean, the number of rows will be 1001, but we have to include this row, 1025th row. Okay, so I hope you got what we are trying to do over here. So we have 1000 1000 rows over here, but as per our whatever requirement, we need to have 1001 row, 1th row, and there we put in this 1025th rows the values. Okay, so we want to extract everything over here and put it here. So how do you do that? So this sometimes becomes complicated. So what we do is we have to assign. Okay, so let's say I'll save it as 1000. Okay, I'll call it 1000. So in this data frame 1000, I will have okay, so I'll in this 1000 data set, I'll have the first 1000 rows without the rows and columns. Okay, now okay, let's just delete this for now. Now I want the 25th, I mean to say 125th, TWEN, the 25th value, okay, in the makeup filter. Okay, so what is the 25th value? So it's in the rows I will put 1025, and in the column I'll say minus C 8 to 10. Basically you don't need a C over here. Minus 8 to 10. Okay, so this is the 25th. Oh, sorry, you need a C because there is a minus sign over here. Yeah, so so this is 1000. Okay, this is 25th. Now if you just want to check them out, let me just delete everything over here. I mean, close everything. Am I audible and visible? I hope so.
Yes.
Okay, okay, thank you.
Yes, sir.
So 1000. Okay, so view 1000. I've just given a very I mean any arbitrary name. Okay, so this is the data frame 1000 where there are about 1000 rows. Okay, and this is the 25th data frame where we have this data set. Okay, so this data set is from here. Make a filter. So 1025th. So this one. Okay, so what I have done is I have just taken this row out over here and saved it in another variable called 25th. Okay, so it has just one row and 7 columns, and I have made another variable called 1000 where I have a subset of 1000 rows. Now I have to combine these two. Okay, I have to combine these two values. So what I can do is I can use a function called cbind. Okay, I can do the first one 1000 and 25th. Oh. And maybe I could use, I don't want to assign any objects over here. Filled thing, yeah, pipe. One thousand. Wait. I think it went. Just a second. Please give me a minute. So what I was doing, yeah. So column binding and 25th transaction number 102. So you have to actually search for that particular, because it has transaction number is 1000. Wait, cbind. Sorry, rbind. So this is okay. So this is the row. So we are binding it row wise. Okay. So 1001, row number 1001, and this is the transaction number, and these are the other details. So we now have a data set consisting of 1001 entries. So this is one kind of operation that we normally have to do or perform when we are working with data in R. So here what we have learned is how to import a data in R. Number one, could it be Excel format, could it be CSV format. Normally these are the two types of data sets we work with, and after we import them, uh, how to view, open it, check the variables in the data frame or the data set, and then how to subset it. Okay, how to subset the file, how to omit your, what can I say, your columns, how to omit rows, okay, and how to combine two sets of data. Okay, so this is what we have done up to now. This is what we have done. So moving on. Okay, so this is also pretty important. Sometimes it's essential for us to understand this concept of pass by value and pass by reference. So what this means is, let's say, uh, I'll use the console for now. Okay, so let's say X, I assign a value, not to X, let me do D. I assign a value 2. Okay, so this is 2. Now, if I do D plus 2, okay, then what is the value of D now? Or what is the output? It is 4. Okay, so D is 2, D plus 2 is 4. Now, can anyone tell me what is the value of D now?
2.
2, yes. Why 2 and why not 4?
So because in the first transaction b is equals to 2, that sign indicates equals 2.
Yes. But we added a value 2, number 2 to the object D. So don't you think the values has changed?
Mm, but it is just we are adding d plus 2. It's not showing d is equals to 2.
Yes. So that is important. So sometimes we might be tempted to believe that we had a variable D with a certain value. Now we have performed certain operations, arithmetic or mathematical operations on it. Let's say we have added 2 or multiplied it by 5, whatever, and then we might believe that now the value of D has changed. It possibly could have changed, as I think Kajul was saying, that we have not assigned any value to it, or we have not assigned, okay, to it, to any other object. So what we could have done now, if you just do print D, it will still show that its value is 2. Now if you do this D plus 2, now you will see that the value has changed. Okay, now if you print, the value of D has changed from 2 to 4. Okay, so this is referencing. Okay, so this is referencing, and this is just pass by value. Okay, so in R we usually have pass by value, okay, and not by pass by reference. So every time you do any operation, until and unless you assign it to some object, then the the results are not actually stored over there. So that's why it's a pass by value. Okay, so this is, I think, we sometimes get confused, and the other confusion could arise sometimes, okay, which normally uh, happens due to the process called coercion. So what is coercion? If you could remember, when we were using the C function, okay, the combine function, what was like, like for example, in this case, 1.7, okay, number, a numeric value, and this is A, I mean, letter A, okay. So there are two different types of elements or objects inside the C function. One is a number, other is a letter or a character. So if you put, so what I'm trying to say is this. So if you do class of one comma two, then if you check the output, it says it's numeric, right? Now if you put 1 comma a, then it says character. Okay, this one understood. The first one was a number, the second was a number. Both of them are numbers, in fact. So the class is numeric. Understood. But this one, I had given a number and a character. But why character and why not a number? Or why not both a number and a character? Why not one stays as a 1 or a number and a stays as a character? Okay, so this actually does not happen when we use some functions. Okay, when we use particularly the C function to combine objects of different classes. So okay, so this is called coercion. Okay, and this usually happens when we are using the C function. Usually occurs in this order. Okay, so if you put a logical and an integer, okay, the entire thing changes to an integer. If you put a logical and a numeric, the entire thing changes to a numeric. If you put an integer and a complex number, or a combination of integer, numeric and complex, then the entire object changes to a complex number or a complex, okay, class. So this happens roughly in this ordering. Okay, so this is something that we have also to keep in mind. And so this is called implicit coercion. You could also do an explicit coercion over here, meaning we could change the class. We could use as dot functions. Okay, so here, so this is the previous one. This is numeric, if you can visualize it, and then I do as dot character. Okay, and then check the class. All right, so it is a character. Now just look at this. This is pretty interesting. So you have supplied 1 and 2, I mean the numbers 1 and 2, but you have changed it to a character. Okay, and tried to check the class of that object, so it's just character. So why did this numeric class change to a character class? Because of explicit coercion. So explicitly or from outside, using the set of functions, using as dot function, we have changed the class of that object from numeric to a character. Okay, this is sometimes useful when we are dealing with data sets. Okay, different kind of data sets, I mean to say. Okay, matrices. So just like the data frame, okay, that we talked about some time ago. So matrices are also a two-dimensional objects. I mean, they are also 2D objects. So it has this dimension attribute. So it has rows and columns. It can contain. I mean, it could but there is a limitation of a matrix. What is the limitation? It can either contain number or a character, or in fact not restricted to these two kind of objects, but a matrix can contain elements of only one class. If it's a numeric object, numeric matrix, I mean the elements are numeric, then all the elements has to be numeric. If it's logical, the elements are logical of values, then all of the elements should be logical values. So you can't have 1 3 then no yes and then again true false. So you can't have a mixture of objects over here, mixture of different class of objects, which is only which is only permissible in in case of a data frame. Excuse me. Is my screen visible?
Yes, sir.
Can you see my screen?
Yes, sir.
Yes, sir.
Yes.
Yes, sir. It is visible.
Okay, okay. I thought I've lost connection. Anyways, so all right. So how do you create a matrix? There's a function called matrix. The first attribute, I mean, the first argument is the vector of elements. Okay, so it could be numbers, it could be anything. Then you have to specify. Then you have to specify the number of rows or number of columns over here. Okay, and this is what a matrix looks like. So the dim function gives you the dimensions of the matrix. Okay, so it has 2 rows and 5 columns, as I said earlier. Please let me know if there's some problem with the network. Length of m, it gives you the number of elements, okay, in the matrix, and the class of m is matrix. It says matrix and an array. Okay, so actually matrix is a 2-dimensional array. So array, it could be some yeah. So yes, then we have yeah. Okay, the other thing is okay, let me just show you this. So what we are doing is we are saying we want to create a matrix, okay, with elements 1 to 10, and there are 2 rows and 5 columns. Okay, so yeah, this one. So no, so 1 2 3 4 5 6 7 8 9 10. So by default, okay, what you see is that the elements over here, or the values over here, 1 to 10, they are arranged column wise. Okay, so like 1 2 and then 3 and then 4 5 6. Okay, so it is arranged by column. Now if you want to uh, do it the other way around, that is, if you want to put it row wise, like 1 2 3 4 5 6 7 8 9 10, then you have to use one more argument in the code, which is called by row. Okay, by row equals to true. By default, this argument is actually set to false. So by row equals to false. sorry, true. You want to set it by row. Okay, so here you go. So 1 2 3 up to 10. So it has been arranged by row. Yeah, so I was talking about the cbind and the rbind functions. But to use the cbind and the rbind functions, what the cbind function does, it combines, okay, the columns. It binds the columns in that sense. And as the name suggests, rbind, you bind the column. I mean, you bind the data sets or the matrix row wise. Okay, so as I had done earlier in this example, the 25th, the 1000 variables. So here also, like for example, matrix 2 rows 5 columns. Let's call this M, and let's bring in M1, and let's say 20, 11 to 20. Okay, so both these matrices, let's check the dimensions, dim M and dim M1. Now what I've done over here is, okay, let me do something else. If you can see this, I have written a pretty long code over here. Okay, so see this. So M matrix 1 to 10, n row 2, and a semicolon, then M1. Okay, and the code ends here, and a semicolon, dim M1. So this is a pretty long line of code. So you can write, so what I'm demonstrating over here is that you can actually write more than one line of code, I mean more than one codes in a single line. Okay, and if you put the cursor anywhere, it could be anywhere. Okay, just put the cursor anywhere and then just press the run button. So the entire all the codes will run, and you'll get the output over here. Okay, so so this is one important characteristic, that you can write more than one lines, I mean more than one codes in a single line and execute it. And the other thing is, you could also if you just want to run one line of code, then just select, or I mean if you want to run one particular code, then you can just select that code and then run. It will just run that code. Okay, so I'll take a break in 2 minutes. So let me just finish this example. So yeah, so what I have done is, I have created matrix M and M1, and I've checked the dimensions. So 2 rows 5 columns of M and 2 rows 5 columns of M2. So both have the same dimensions. So what can I do? What I can do now is, I can do a C binding or R binding. So I can do C bind, okay, M and M1. This is what the output will look like. Okay, again some more. So what I'm trying to do is that, since the output, it didn't fit in, this didn't fit in one line, I'm just making some space for the matrix over here. So now the matrix is it fits well. So 1 to 5, 6 to 10, and 11 to 15. So I have combined them column wise, or I bind them column wise. I could also do a row binding over here, and I put it now. This is the second matrix, and this is the first matrix. Okay, so this is what I did for did in this example. If you are a bit unclear of what I had done over here, so let me take a break now, if Dayaji permits.
Yes, sir. Sure, sure.
Let's take let's take a 10 to 15 minutes break,
Sure.
and 4:30 I will join again.
Okay, okay.
So I'll join at 4:30 then. Okay.
Okay, sir.
Yeah. Thank you. Thank you. So let us continue. Okay. If you are not able to
Yes, sir. Yes,
see
sir.
my
You can start.
screen, yes, Dayaji. Okay. So if you don't see my screen or don't hear me, please let me know. So we can use the cbind and the rbind functions to combine our the data frame or a matrix. Okay. Subsetting, again, the subsetting rules that we have discussed. We use this operator, the bracket, okay, to subset. So for instance, in this example, we have a matrix called X. It has elements 1 to 10, 2 rows and 5 columns. Okay. So if you want this, if you want to subset the element in row 1 and the second column, that is this number 3. Okay, if you want to extract this or subset this, then you do X subset the first row and the second column. Okay, so it will extract the so this is the position, that is 1 comma 2. Okay. Similarly, 2 comma 5 is again the first one is for row, so 2 and 5, this is the element 10. If you do not specify anything in the rows place, then it will keep all the elements in the row. Like in this example, X bracket, you don't have anything specified in the rows place, so you'll find all the elements of the row, that is 3, 4, uh, 3 and 4, okay, in the row. So these values 3 and 4, and it will keep the second column. All right. Now this might be uh, visually confusing. So what I'm trying to say is this. Let's say, so we have this matrix. Okay, so we want the elements two which elements 3 and 4, these two elements as the output. Okay. So what we do is we take X and subset all the elements in the row and the second column, 3, 4. But again, as I was saying, visually this is confusing in the sense that there's this argument, okay, that you can use drop. Okay, so if you use drop, this argument called drop equals false, then this is the output. So visually now you can understand. Okay, it's not like, you can also clearly see that you have extracted these 3 and 4 values. Okay, the 3, 4, the elements 3 and 4, the numbers 3 and 4 in this matrix over here. So you can use this drop argument again. You might be wondering, like, how to understand. So again, you have to make use of the help function as much as possible to know about the different arguments used in a function. Okay. So there are many examples over here. So what I suggest you is, I think you have been able to access this material that I have sent you via the AG. So what you do is you keep this open in one window, okay, and then instead of copy pasting it, you just type in these codes in your R script and then check the output. Okay, so the output is also displayed over here. So you should get, so that is the best way of practicing. So these are the codes and these are the outputs, so you just try to replicate them. So that is how you practice. So sometimes what we tend to do is we just read it like a storybook, or just normal text. Okay, so that is not how we should practice. We should again open our R script and then type in the codes and then check for yourself whether it's working or not. Okay, so please do that.
So what is the
So
meaning
what
of
is the meaning of
why row?
why?
By row.
E.
Where was that? This one.
Yes.
Can you see the highlighted? Yeah.
Yes.
So this means that M. So look at this matrix M. Okay.
I think sir lost the connection, no? Please wait.
Yes, sir.
Within 2 minutes, Dr. Tamang may connect. Just try calling. खुशबू समझ में आ रहा है? खुशबू कुमारी, आपको आ रहा है समझ में?
जी सर, आ रहा है सर।
ठीक है, तकलीफ होगा थोड़ा बहुत, इनिशियली सभी को होता है, बट
जी
सुनते 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 आप सिस्टम को समझ जाइएगा।
जी सर, जी सर।
ठीक है, Okay.
जी सर.
Actually, there was a network error. I hope you
Yes,
can see me.
we know that. That's why I
Yes.
showed you.
Yeah, yeah. Thank you. Okay, now I think you can see my screen.
Yes, sir.
Yes.
Yes,
So we have a matrix M. Okay, so if you print M, then you'll see that what we are saying is that 1 to 10. Okay, so the numbers, these are the elements of this matrix. Okay, so by default, when we create a matrix using the matrix function, what happens is that the elements 1 to 10 are arranged column wise. Okay, by column. So the first element 1 goes here, and the second element 2 goes over here. 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so to give you another example, let's do it like 11 to 20. Yeah, and then M. So 11, 12, 13, 14, 15, 16. So serially it is placed in columns, okay, by default. Now but you don't want them to be like, but you want 12 to appear here, then 13, then 14, then 15. Okay, then what you do is you use one more argument called by row equals true. What this does is it actually now look at the difference of here. So this was like 11, the first row was 11, 13, 15, 17, 19. Now the row is 11, 12, 13, 14, and 15. So when you use this argument by row equals true, the elements are arranged row wise.
Okay, sir. Thank you.
Okay. Okay, so what I was saying is yes, so the drop argument, okay, in the matrix function, the drop argument, what it normally does is uh, the output the format of the output changes. Okay, so normally when you subset a matrix or a data frame, okay, then the format of the output, okay, like it no longer remains uh, it no longer remains the way it was, or it does not remain according to its parent of data or object. Okay, so its parent object was of class matrix, but now after subsetting it has changed, so it no longer is a matrix now. Okay, so if you want to keep its format intact, then you can use the drop equals to false argument. Okay, so this does not allow the subsetting rule or the subsetting function to drop the format of the object. So that's why you use this drop argument over here. Yeah, so we have done this earlier also. So the diag function extracts the diagonal values in a matrix. Okay. So in this example, we try to name the columns and the rows. Okay, we will name the rows and the columns. For instance, okay, it's the same matrix over here. M. Okay, so let's say we want, instead of these values over here or the column numbers and these row numbers, let's say we want to give a suitable name to the rows and the columns. So you can just imagine it in an Excel spreadsheet where you are actually giving row names and column names. So there's this function called call names. Okay, so we say that for column names, so give column names to M. Okay, and then C, here we can use the make use of the functions like your paste function or the repeat function. Okay, so we could do that as well. Okay, what I'll do is I will, okay, let me do this first and then I'll give you that example. Call names M, and we can say this one, okay, as in the example over here. Okay, so this one is 1 2 3 4 5. Five, 1 2 3 4 5. Yes, so 5, we have supplied 5 names, column names, okay, or the headers. Instead of 1 2 3 4 5, we want these names to be displayed over here. Okay, and we said that the column names of the matrix M should be assigned these values. So that's the literal translation over here. And then if you check M, you'll see that the column names have changed. Similarly, we have this row names function. Okay, and then we can give any name to the rows. So here let's say first one will is temperature and the second row is what, it's a time. This is just an example. So if you do M, then instead of this 1 and 2, okay, so we have temperature and time as the row names. So this way we can assign row names and column names. Assigning row names and column names for matrices is, I mean, for data frame is also the same process. Okay, so if you have a data frame instead of a matrix, then you can also assign row and the column names in the same fashion, in the same way. Now in this case, I have given an example over here. If you look at question number 14, okay, so you have to create this matrix. Okay, so where you could have up to 40, right? So econ 01, econ 02, these are the row names over here, and these are the values, some values over here. So basically a matrix that you create, and these are the column names. So assigning column names won't be a problem because there are 1 2 3 4 names. Okay, and for this matrix you assign these 4 column names over here. It's the same thing that we have done over here. Column names MC C, okay, so on and so forth. But for this row names, so now you have to create about 40 names. So instead of typing out 40 names, right? So instead of typing out like 40 words. So basically what you could do is look at the letters, look at the words over here. So one is econ 01, econ 02, econ 03. So they are repeating over here. Okay, so many things are repeating, like the word econ is repeating, and 01, 02, 03. Okay, so these numbers, okay, so these numbers, okay, so yeah, so these numbers are again a sequence of numbers from 1 to 40. Okay, so you want to create this matrix over here. So how do you do that? You can use the paste function and the repeat function. Okay, so first you could say paste. Okay, then econ, okay, and numbers 1 to 40. So if you do this, you can see that you have econ 1, econ 2, so on and so forth. So you're getting some kind of a format over here, and then separated the SEP function over, I mean the argument over here, by nothing. So you've generated the names, the row names, without any difficulty over here. Okay, so now you can assign this to any object. Okay, and then you can use that object as a column, row names, as row names. Okay. So moving on, logical operators. Okay, so logical operators are very helpful when we are actually working with functions. And we can use logical operators on data frame, matrices, factors. Okay, so we can so that's why logical operators become very useful. I have given a table over here with the kind of operator, okay, and the interpretation of that operator and the results that you get out of these operations. Okay, so one example that I can show over here is, and yeah, there's one thing, like in the AND, OR, and the NOT operators. Okay, there are this element wise operation taking place and the single comparison. Okay, but not in the NOT operator. So the element wise and the single comparison operations that take place with these operators, let me just explain that. Okay, so let's say that we have logical, we have an object A, okay, which contains logical values true, false, true, false. Okay, and this is B. So let me just copy this. Okay, anyways, I'll just show it from here only. So A, it contains the logical values true, false, true, false, as you can see the output over here. B contains the logical values false, true, false, true, true, true. Okay, now when you do the single AND and the double AND operations, these are the outputs that you get. The first one is the output of this single AND operation, and this output, okay, is the output of this double AND operation. What happens in case of a single AND operation is, when you use this single AND operator, look at the elements. The first element is true, the first element of A is true, and the first element of B is false. So we are saying A and B, Now you go back to the table. Since this is a single operation taking place, it will be an element wise operation, and you have a true and a false operation taking place. Okay, so if you look at the results, a true and a false single AND will give you false. So the answer should be false. The output should be false. So true and false single AND will be false. True and false is false. Okay. Now there are 4 elements in A and 4 elements in B. When we are doing a single AND operation, all of these elements, they, the operation takes place in all of these elements. Okay, so that's why this single AND is called element wise operation taking place. So true false gives you false. Second element false true gives you false. Third element true true gives you true. Third last element false, and the last element of B true gives you false. So in the single AND operation, there is element wise operation taking place, and the number of output, okay, or the number of elements in the output is the same as in the A and the B objects, logical vectors A and B. Okay, that is because we are having a element wise operation. Now when you are using double AND operator, okay, so what happens is that there only a single comparison takes place, or a single operation takes place. Okay, so only the first element, okay, of A and first element of B interact, or in the sense, they are put into operation, and the output is stored false. So true, the first element in the vector A, false, the first element in the vector B. Okay, they are operated, and then the result is false, which is saved in, which is basically saved, which is the output using the double AND operator. I hope this is clear. And similarly, for OR operator and the double OR operator, similar operations take place. Okay, so as I was saying, subsetting and extraction can also be done using the logical values. For example, this is a numeric vector. Okay, now you can actually subset or extract. Let's say you just want the negative values, okay, in the vector. You want to extract the negative values, so you can use a series of true false flags over here. So give a ft f. So you want to retrieve, or you want to keep or extract this number. So in the second place you give a true t, and the rest you give f, and again this last element, which is negative, since you want to extract this value, you keep a t over here. You give a t or a true. So this is one way of extracting okay, using the logical flags. Next is your this okay, so not this one. You could also use t and f. Okay, so you could also use, am I audible? And Is my screen visible?
Yes, sir.
Yes, sir.
Okay, thank you. So you could also use the T and F flags, okay, and sometimes you can use its recycling power. I mean, what happens is that, so instead of doing this, okay, TF and F, providing a sequence of flags T and F, you could use one T and one F over here. Okay, so what this does is it keeps recycling until uh, the entire vector, until the all the elements, okay, the operation takes place on all the elements. So the point is, okay, I'll just show you I'll just give you a demonstration over here. So my vec, so this is the list of vectors over here. Again, yeah, so this one, okay. So let's say you want to keep so what you could do is, so you, let's say you want to keep the first element and not the second, the third, not the fourth, okay. So you want to keep the all the odd numbered elements, so you could do this myvec and this bracket, and you could give a T, then F, T and F. Okay, there are 10 elements, so 1 2 3 4 5 6 7 8 9 10 10. So you could either do this, you could either incorrect number of dimensions. See, so either do this, okay, so you getting 5, then 4, then 4, then 8, then 4 0 2 2 1, okay. Or what you could do is, instead of this typing a lot of T's and F's, so you could do T and a F, so it will also give you the same result. So what's happening is that uh, this subsetting, or this subsetting rule, or using the brackets, what actually happens is that, when you are using this bracket, until and unless it checks on all the elements, okay, um, you know or the operation, the operation is done in all the elements of the vector. Okay, so when you just supply two elements over here, logical elements, okay, T and F, so it keeps recycling itself. So this checks for T over here, it gives this, and then the second one is F, so it rejects this, but still there are other elements. So for the third one, it by default considers this flag vector T, so it gives this, and for the fourth it considers this F, so it rejects this fourth element over here. And then again, similarly it keeps recycling until and unless this the subsetting function it completes its operation on all of the elements in that vector. All right. Okay. Characters, factors. Okay, quickly, let me just do.
Sir, I'm not able to operate this code my way.
My way. Okay.
There is some error in my desktop.
What error is it showing?
Is less than mark. Yeah,
Less.
it's happened. Okay, thank you. I got it.
Okay. All right. So let me just do a bit on characters. Okay, character vectors. So for a quick understanding, I'll just show it you from the this notes only. So this is a character string. Okay, so I've written a sentence over here. Okay, so I could okay, let me just to give a demo only. So my name, okay, I'll call it my name, and I'll type in my name. I'll put a sentence, let's say. So if I do my name, so this is a string, character string. Okay, my name. So if I do class of my name, it will show me character. If I do length of my name, it will show me 1. That means although I have many words, like my name is Pravesh, 1 2 3 5 words, there are 5 words in this sentence, but the length is saying that there's only one, the length is 1. Basically what it means is that within quotes, okay, so there's only one sentence or anything within quotes. All right, so let's do something else. My address is let's say I want to give my full address. Okay, so I use a C function now. I give my name, and then I say this is my address. Okay, so let's do this. So if I do my add, then this will show me 3 strings over here, which means if I do length,
So again, network issue. How many you are simultaneously practicing the instructions? How many? One or two? I see that. Yes, sir. Yes, yes, ma'am.
sorry Dayaji, actually
No,
after like during the evening time, the network really, there's network
no,
problem in my area. So
sir. Joe have seen a question. Continue, please.
yes, thank you. Can you see my screen?
Yes, sir. Yeah.
Okay, thank you. So what I was saying is that when you create when you create a character vector like my name or my ad, okay, so and check the attributes like length or class, okay. So here it says that the length of this character string is 3 because there are 3 strings over here, okay. So a string is composed of a sentence or a word, okay. So whatever there is within the quote is actually a string. This is a string, okay. So the point that I wanted to make was, yeah, so length, so that is one. The other is nchar, okay. So it gives you the number of characters of my, so in my vector my name there are 25 characters, okay. So what is my name? This is my name, and number of characters nchar, okay. So 25, like starting from the letter M up to the letter G, okay. So there are 25 characters including the spaces over here, all right, including the space. So uh, this is important to understand. Now sometimes you, okay, so sometimes you need to do some formatting, okay, of characters. So there are certain escape sequences that we must understand, like a backslash and an n will start a new line. A backslash t will uh, it will invoke a horizontal tab. A backslash b will invoke a backspace, okay, and likewise this will include a double quote, all right. So if you look at this function, okay, cat, okay, it's a function. You can get the help on cat function, okay. So what we are doing over here, if you execute this line, now look at this output, okay, look at this output. So here is a string split to new lines. So this string is split to 1 2 3 lines, and there's a gap over here. This line is blank. There's a tab over here. There is a space over here. There are 2 tabs over here. So how do you get this output? Okay, so you type the string. Here is a string, and you give a backslash and an n. So what this means is that after this, whatever comes will be in a new line. So split moves to a new line. But remember, did I lose the internet or what? No. So so after split, you can see over here you have a space, okay. I mean, before split you have a space over here, all right. So you can find a space over here as well. So if you do the same over here, and if you bring this closer to n, you can see that this split has moved 1 space back over here, okay. There's no space over here. So all these things become very important when we are actually working with characters in R, okay. A backslash t will invoke a tab, okay. So a big tab over here. Tab means the tab button in your keyboard, okay, to new. And this b invokes a backspace. Now if you see in the code, I have specified double w's over here, NEWW, okay. So this could be but in the output you can just see one w. Why? Because here because I have put a backslash b, it is going to invoke one backspace and delete this w over here, okay. If you do the same over here, and in lines, if I do a backslash b, okay, I think this is visible over here, okay, at the end over here. So if I do a \b and check the output, you see sorry, li nes. No, this is not working here. Lines lines double backslash p will invoke a double backslash. Okay, sometimes what happens is that even in because you'd be using different internet gone. Okay, so sometimes there's a problem because you are using different kind of uh, what should I say, computers over here. So like for example here also I got an error over here, so I couldn't invoke a backspace over here. Okay, so there's double w over here also, so this will be fixed. Okay, I'll please try this out later also. The other, yeah, so the main thing that I wanted to talk about was uh, you know subsetting. Okay, subsetting rules are very important for all kind of vectors, including your strings also, character strings also. So so substring, okay, uh, let me take this example because it's already done. Yes, okay, this is a character string. So if you do substring substr, so what you have done is in this entire string code of string, you by using the substr function, okay, so substring this or subset this string start at 11 and stop at 19, meaning that you start from the 11th, you start at the 11th, what should I say, letter over here. Okay, so 1 2 3 4 5 6 7 8 9 10 11, so you start at C and stop at 19, then 12 13 14 15 16 17 18 19, so you stop at R. So it will just extract this word character over here. So this is what it has done. Okay.
Sir, sir, your second one is disconnected.
Okay, Daji, I'm trying to reconnect again. Can you see the screen now?
Not yet, sir.
No, sir.
Can you see my screen?
Yes, sir.
Okay, thank you. So what I was saying is, uh, so this is like subsetting, okay, similar to subsetting a matrix or a data frame, okay, and we are doing subsetting on your character strings. So one function is substr, okay, which takes a string and extracts the part of the string between two character position inclusive, right? Uh, you can also change, okay, change a particular word or a letter in a particular string, okay, by just assigning, okay, just like this. So if you do, so what you are doing over here is, and now if you, so what you have done over here is, so you have said that extract, or I mean subset this, what should I say, letter or a word, okay. So start in the string s, you start at 11 and stop at 19. So what R does is it identifies the word or the letter, in fact it identifies those positions, okay, and then it replaces it with the word or any letter or any character that you provide, okay, or any string, character string that you provide. So if you run if you, after you run this, you will see that the string changes, okay, and the word character is changed to a to this capital, okay, letters. The other thing is, I'll give you an example, and I think that should be okay. So here, this is the question. So here's a here's a paragraph, and in this paragraph there are commas, okay, there are non-alphabetical characters like quotations, okay, so on and so forth. So in this entire paragraph, what you have to do is you have to remove all the non-alphabetical characters, okay, like commas, like quotes, okay, semicolons, all right, brackets as well, okay. So to do this, you need a package called mgsub. Okay, so mgsub. So what mgsub does is it gives you option, okay, of identifying multiple patterns and the replacement rules, okay. So like quotes, all right, like quotes or something else. So you can have multiple patterns in mgsub, okay. So for instance, if you look at this example, so in this so here we are using gsub and sub. These are the two functions that we're using, okay. So in this sentence, okay, in this sentence we want to replace this word duck, duck, by the word dog, 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 okay. So when we use sub, what happens is that it identifies only one pattern. I mean, it identifies only one pattern, and number two, it can replace only one element, or like let's say one word over there. Okay, so instead of duck, Okay, so let me put it the other way. So this way it will be easier for you to understand. Okay, and I go to dog. So if you look at duck, it says this is a sentence. Now if you look at dog, the other object that we have, so let me just, this is what I wanted to change. Replacement QUACK. Okay, yes. So now let me clear dog and duck, DUCK and DOG. Okay, so if you look at the codes, okay, and okay, this code at least. So here what you are saying is that identify the pattern quack, okay, in this duck, okay, in this duck string, character string, and replace it with the word dog, dog. Okay, so this one, okay, Dayaji, what should I do now? Like, my internet is also, getting disturbed frequently, and
No, you can, sir, just wrap up.
yeah,
No
yeah,
problem.
yeah. So, yeah, yeah.
I know that you are on the hill. That's why connection is problem.
Yes, yes. Usually in the late evenings, the network is very bad.
Hmm. Due to
Difficult
weather.
to get a connection.
No problem, issue.
Yeah. So, there are actually a lot of things. So that needs, like, lot of explanations need to be done, but I don't, and it's particular, like, very difficult to cover all the topics that I was asked to cover, okay, in a day. So but still I have given you, I've tried to explain some of the basic ideas, okay, or some of the basic notions that would help you learn further on your own as well. uh, and you can go through this you know HTML file that I provided to you, and like, if you need any help anytime, you can email me if you want to. I hope this session has been fruitful. You have been able to understand to whatever capacity I've been able to make you understand. Thank you all for joining, and especially thank you so much, Dayada, for inviting me in this seminar.